Good morning and a warm welcome to this Baltic Breakfast a few days before Christmas. We will talk about climate change today and its impacts on the Baltic Sea. My name is Anna Rutgersson and I will be moderating today, and I work for the Stockholm University Baltic Sea Centre. Well, climate change is already happening, you know that, and it is already affecting the Baltic Sea. But by taking part of today's webinar, you will get the latest research and you will know more about what you can actually say with certainty. And we who organize, it's the Stockholm University Baltic Sea Centre, and we work with all the different environmental problems affecting the Baltic Sea, you know, from source to sea. We have 3 different areas of operation. There's an infrastructure, a field station at Askö. There's of course enormous interesting research going on, but we also focus on communication and policy issues. And that's why we're here today, trying to bridge the gap between science and policy. All right, so let's talk about today's topic a bit. You can, during today's issue, you can post questions, of course. And we will try to deal with the questions during the seminar, but if we don't manage that, we will deal with them afterwards and try to put answers on our web. You can either send questions via Twitter, Ostersjöcentrum, hashtag Baltic Breakfast, or email us at ostersjöcentrum.su.se or Slido. And the code is 221002, and you can see it in the picture, I think. All right, let's get today a bit more into today's topic. As I said, we all know that climate change is already affecting the Baltic Sea. And the sea is under severe stress from different pressures. Pollution in the form of nitrogen and phosphorus drain from land, they causes eutrophication. Hazardous chemicals end up in the sea, biodiversity is lost, and so on. And on top of this, there's climate change. And so what can we actually say about how the ecosystem will respond to these changes? That's a really tricky question to answer. But there is new research out there that will help us with a high degree of certainty actually answer these questions. And we have 2 interesting speakers with us today. And first is Professor Dr. Markus Meier, who's the head of Department Physical Oceanography and Instrumentation at Leibniz Institute for Baltic Sea Research at Warnemünde. And he's also a senior scientist at the Swedish Meteorological and Hydrological Institute, SMHI for you Swedes. And he is also chairing a Baltic Earth Sciences Steering Group and co-chair of the Baltic Earth HELCOM Expert Network on Climate Change, CLIME, and you will be hearing more about CLIME. And after Professor Meier, we will be followed by Professor Anna Rutgersson, who is from the Department of Earth Sciences, Program for Air, Water and Landscape Sciences, Meteorology at Uppsala University. And she'll be talking more about the effects of extreme events and natural hazards in the Baltic Sea catchment area. But we will start with Professor Meier, and he will guide us through and give us the overview of summarizing climate change impacts on the Baltic Sea. So please, Markus, welcome to this webinar.
Thank you very much, Gun. Good morning, ladies and gentlemen. I would like to share my screen. And I will talk about the impact of climate change, as Gun said, from latest research. And this is an assessment. And in brief, this group CLIME found out the following key messages. That global warming is going on, and warming is also warming the Baltic Sea. So the projected sea surface temperature increase between 1 and 3 degrees, depending on the greenhouse gas emission scenarios. So the RCP 2.6 is more or less the Paris Agreement, or some worst case the RCP 8.5. And this is, these numbers are valid for the end of this century compared to a reference period. In the future, it is also very likely that the maximum sea ice extent will further decrease. Salinity is a tricky parameter. It depends on the freshwater supply, on wind, and the global sea level rise. And as these projections for these parameters are rather uncertain, also salinity projections are uncertain, and we cannot clearly say where how salinity will change. Global sea level will rise, and consequently the Baltic Sea level as well, maybe a little bit less than the global mean, but it will increase. But in the northern Baltic Sea area, this increase is counteracted by land uplift, partly or more than compensated actually. And finally, we have the Baltic Sea Action Plan, that is nutrient load reduction, and if this will be implemented, this will lead to significantly improved deep water oxygen conditions, irrespective of the climate projections. So climate change will lead to a worsening of the eutrophication and environmental condition in the Baltic Sea, but will not completely counteract the ambitious Baltic Sea Action Plan. So where is this information coming from? This is from a fact sheet, Climate Change in the Baltic Sea, this fact sheet was produced by HELCOM together with Baltic Earth. Baltic Earth is an expert network, and this group that produced it, more than 100-person scientists participated, is called CLIME, the expert network on climate change. And in very brief format, 34 parameters have been addressed in this fact sheet about past changes. Also, what do we know about ongoing changes related to global warming, and what is projected, but also about knowledge gaps and policy relevance. And you can find the fact sheet under this link. It has been published, the fact sheet has been published on the 3rd of September. Here is the list of parameters. First, we have direct parameters like air temperature, water temperature. And so it is, the parameters are ordered according to cycles: energy cycle, water cycle, carbon and nutrient cycle, sea level and wind. But also, and these parameters we call secondary parameters, parameters of the biota and ecosystem were addressed, and on human activities and services. I will come back to a few of them in the following slides. So first, about the present ongoing climate change. So this is the change that happened during the instrumental period, when we have observations from measurements. Air temperature over land, this is increasing. This graph here shows the for the different season and the annual mean, all available land station in the Baltic catchment area. And the blue curve and the red curve are showing the Baltic Sea Basin region north and south of 60° north. And there is a smooth curve shown, and the dots are the annual values. And what you clearly can see, that there is a winter increase during winter and spring. And the increase actually in the Baltic Sea region is larger than the global average. It is also slightly larger than in previous assessments. So Baltic Earth has done this kind of assessments, regional IPCC reports before. And compared to these earlier assessments, the first was actually published in 2008, there has been an acceleration observed. For other parameters, it's more difficult. This here shows runoff for different basins from Sweden. If you take the runoff from land from the entire catchment area, you cannot detect any significant trend. But if you look into the different basins, and especially into the north, the part of Sweden that discharges into the bottom bay, there is an increase, or an increase has happened during the past 3 decades. This is an important parameter because it affects salinity in the Baltic Sea. Here you see the historical record of sea surface salinity for the entire Baltic Sea, and in red and simulation or a reconstruction, one can say. And you see a pronounced multi-decadal variability, but no significant trend. And this reflects the fact that the runoff has also no trend during the past 100 or even more years. But if you take only the salinity in the very north and compare the gradient or the difference of this surface salinity in the north with the southern region, then we can show that there is an increase in the gradient. That means that the north is actually decreasing compared to the south. And this indicates the increase in fresh water in the very north. Sea level is rising. This graph shows the sea levels from 14 Swedish stations since 1886. The data are corrected for land uplift. Due to the last glaciation, the land is rising. That has to be subtracted, as I mentioned in my key message before. It's actually counteracting in the north, but if you take that away, this land uplift, you see clearly a 20-25 centimeter increase during the past 100-150 years. For the future, we found in this assessment an increase in the temperature. You see here the winter panels for the region. That's the upper row. December, January, February, and the lower row shows June, July, August, the summer increases. And the different columns are the different greenhouse gas emissions. So from Paris, RCP 2.6 to the worst case, RCP 8.5. So from 1.5 degree on average increase to 4.3. You can clearly see the largest warming is going on in the northeast in wintertime, and the land is warming more than the sea. For precipitation, the figure is clear for the winter. So overall, an increase in precipitation during wintertime. But in summer, for the southern region, it's not really clear. It's around the 0 line, and it depends really on the global climate model. So the uncertainty is large concerning the sign of the change. But clear is that also here in summer, the north will be getting wetter in the projections. And as I explained in the beginning, these different factors, runoff, so the precipitation over land minus the evaporation, the sea level rise in the global mean, because that affects the saltwater inflows from the North Sea, and the wind that also has an impact on the exchange with the North Sea. These 3 parameters affect salinity. And as there is a large uncertainty in the projection for all 3 of them, for runoff, for instance, it's in the range between 2 to 20%, although it's clear that the projections suggest an increase in precipitation. The different scenarios differ quite a lot. For sea level, the global mean changes in the ensemble mean between 40 centimeter in the low case scenario to 80 centimeters. And the wind is rather unclear if there are any significant changes. So due to these uncertainties, salinity is rather uncertain. Finally, what does it mean for secondary parameters like oxygen? Well, actually the warming counteracts the oxygen content in the Baltic Sea, and what you see here is hypoxic area. This is the bottom area with an oxygen smaller than 2 milliliter per liter. So one can say these are the dead bottoms. Due to eutrophication, in the Baltic Sea. It has increased quite a lot during the 50s and 60s with a maximum in the 80s. This is the black curve. And then there are the different colored curves in this graph showing the projections to the future. And all of these projections have been combined with climate change. But the different colors here denote different nutrient load scenarios. The green one is the Baltic Sea Action Plan, so an ambitious reduction in nutrient loads to the sea. Then they have the reference conditions from today's climate and some worst case that is taking into account even an increase in the population in the catchment. And despite climate change, so that's the good news, the Baltic Sea Action Plan works. It is counteracting, one can show this. So there's an effect from the warming that results in a smaller decrease than under present climate, but it's not completely counteracting the efforts. So here, this is just as an illustration. We have a map in the fact sheet where we have information from the different parameters. These are the different symbols that you can see here in the map. And in the boxes, you have text about the most important ongoing, projected changes for the RCP 4.5 climate scenario. That's a medium range scenario for the different basins. So you're welcome to have a look into it, and I thank you very much for your attention. And I would also like to thank all the authors, the more than 100 colleagues that contributed to the production of this fact sheet. Thank you very much.
Thank you, Markus, for sort of walking us through this enormous amount of data and information. I'm really impressed. I tried to open the fact sheet. You know, in my head, a fact sheet was a few pages, and it's actually a thick report with a lot of really interesting information. So I really recommend all you viewers to go to this fact sheet. So if I understand you correctly, then you're actually saying that change will happen. It's already happening. But there are so vast differences between different parts of the Baltic Sea, so one has to think about it in a regional perspective. Is that correct?
That's definitely correct. So it depends on the region and it depends on the parameter. One can say the world is getting warmer, and especially the Baltic Sea region is getting warmer. And all parameters that depend directly on temperature, on air temperature and then water temperature, are seriously affected. That is also true for the ecosystem. For instance, growth rates or so will change. But then we have larger uncertainties in other parameters related, for instance, to the water cycle because of the uncertainty I'm talking about in precipitation. And finally, the regional differences. Yes, that is true because we have the global sea level rise. And this will also rise the sea level in the Baltic Sea in the mean. But we have land uplift. And in the very north, land uplift is large. It counteracts the sea level rise, or is even larger depending on the projection. And in the south, the land uplift is rather small. So it depends critically if you're in the entrance area of the Baltic Sea or if you're in the northern Baltic Sea, what's happening with the sea level and sea level extremes.
Mm-hmm. So the whole CLIME project and work, as you said, it deepened your understanding and also made it possible with a high degree of certainty to talk about these things. And you explained the issue of salinity, because I think that among most of us who work with the Baltic Sea, that fact that salinity will decrease has gotten stuck. But you're actually saying it's not certain. It depends again among runoff, etc. Is that so? Yeah.
Yeah, it's completely correct. So we are pretty sure that precipitation on average, so averaged over the whole year, will increase in the Baltic Sea region. At least is certain what we can be certain about our models. They agree somehow in this signal. And increase in precipitation is meaning that there is a decrease in salinity. But salinity does not depend only on precipitation, on the fresh water supply from land. It depends also on the exchange, the water exchange with the North Sea. So high saline water is coming from the North Sea, and if there is an increase in sea level, more salty water is coming from the North Sea, counteracting the effect from the freshening in the air from the northern part of the Baltic Sea basin. And this interplay makes finally the change in average salinity, so averaged over the entire basin. And the different parameters are rather uncertain. For instance, projected ensemble mean sea level for the globe differ between 40 centimeters and 80 centimeters according to the IPCC. That's quite a lot.
Yes, a lot.
And actually the difference compared to earlier assessment, what we learned in recent years is that this salinity rise is quite important. Even if we talk about numbers of 40 and 80 centimeters, it matters quite a lot for the salinity. And that has not been included and has not been studied in so much detail in earlier assessments. Okay. There's another important thing I may add here, Gun, if you allow. The uncertainty. The uncertainty is large, but we have now more and larger model assembles. That means that we have a possibility to better estimate this uncertainty. And I think that's a good thing, that we can say for some parameters, okay, here the models definitely do not agree. We do not know what will happen. And for other parameters, we are even more sure. And we have now a tool to estimate these uncertainties.
Okay. Thank you, Markus. We will get back to what to do and policy issues, etc. But first, let's hear from Anna Rutgersson, professor at Uppsala University. And Anna will talk us through more about extreme weather events and natural hazards in the Baltic Sea catchment area. So Anna, please, the floor is yours.
Thank you, and good morning, ladies and gentlemen. I will share my screen. Let's see if I can make it big. So, I will talk about natural hazards and extreme events in the Baltic Sea region. And of course, climate is a concern, but what impacts people is often, and what generates natural hazards is the extreme events. So, knowing about an average change of the climate is of course important, but knowing about possible changes in extreme events is even more important for society to be able to adapt. I will talk about a review we have done over the Baltic Sea catchment area on natural hazards and extreme events and the changes in a changing climate.
Anna, sorry, I think it's not in presenter view.
Isn't it?
No, it's still showing sort of your side slides, but just maybe they can get a picture larger.
Is it slow, maybe?
Maybe it's slow. Okay.
In my screen, it is on.
Okay, so maybe it's happening. Please go on. We still see the pictures well enough.
But you only see the first picture, right?
Yes, that's true.
It's very strange. So I try to stop sharing and see what happens.
Okay, we'll do it again.
Sorry about it.
No, it's fine. I mean, these things happen. But we hear you nice and well. No, that's better. Thank you.
Okay, great. Okay, yes. So why do we want to know about extreme events? Of course, it is because they link to the natural hazards. And here is an example from an reinsurance company showing extreme events or hazards during the past 30 years. And here we can see that it's estimated based on fatalities or based on costs. So what is extreme depends on what we are worried about. And we can see that for the Baltic Sea, we are quite good out compared to a lot of southern European regions. But when it comes to fatalities, it is this orange color that is the most problematic, which is extreme temperatures, droughts, and forest fires. But when it comes to costs, it's more problematic with storms and flooding. So it depends on what we are looking at. So now I cannot change. So, yes. So what are we interested in? What are the relevant parameters? Of course, for natural hazards, it is the human fatalities that is considered the most major problem, but also economic losses. But we could also see ecosystem degradation as a problem when we talk about natural hazards. Implications, if we look at the implications for society with extreme events, one could look at a number of aspects, but what we did in our study and what are crucial factors are shipping, forest fires, coastal flooding, offshore activities, and dams and other infrastructures that are sensitive for extreme events. And what is extreme? Of course, on the shorter time scales, we have storms, we can have extreme waves in sea level, ice ridging, precipitation. For example, snow cannons is something that we have in the Baltic Sea region, and river floods. But also longer term events can cause large problems to society. And here we have examples being heat waves. Also phytoplankton blooms can be problematic, ice season and drying. So in an extreme event, we have the magnitude of the extreme, but we have also the extent of a certain condition that can make an extreme event problematic for society. If we look at factors governing extreme events, we have the larger scale, we have North Atlantic Oscillation, we have the climate change. We have aspects happening on a seasonal scale, we have cyclones, we have blocking situations. And then we have what happens when these events occur on the smaller scale. And then it is factors like how much precipitation and how large temperature, how high temperature we have are important. When we go to marine events, of course, the ice and the sea level are important factors. And these are not separated, of course. We have a complex interaction between different events that can be problematic when we look at the impacts. So what we have done here is to look at the present conditions, what is really happening and the changes that we have seen for the past decades, and what is projected to happen in the future. How do we see these changes to happen in models for climate models? I will show you some examples that we have been looking at and then summarize the larger pictures. So heat waves, but also cold spells is something that is important. And what we have seen from the heat waves is that there is an increase in the number of days defined as in heat waves, as in heat wave. And here the two left figures indicate the heat wave. So on the top is an heat wave index, and we have seen an increase from 1950 to 2020. On the bottom is number of days with increasing heat waves. So there is a potential of an increase up to 18, 20 days a year in some parts of the Baltic Sea region. But when it comes to cold spells, it's also a problematic feature for society to adapt to. Then we have seen a decrease in the cold spell index and a decrease in the number of days with cold spells during, on the average during the year. So this has been seen in the past decades, and the climate change scenarios indicate that this is projected to continue in the future, with increased number of days with heat waves and a decrease in the number of days with cold spells. Another important factor when we talk about extreme events is the precipitation. And in general, we can say that a global warming is associated with an intensification of the global hydrological cycle. And this we can also see when we look at the regional events in the Baltic Sea region. And the lower figure here is the number of cases with heavy precipitation. And this example is shown from two places in Lithuania, but it's a general pattern also for other parts of the Baltic Sea. So there is an increase in number of days with heavy precipitation. So this is for the past, and for the future. What can be seen for the future for climate models is that heavy precipitation is projected to increase in intensity. So here is a model simulation again, and here is the highest 10 percentile of the daily precipitation change between, and there is a difference between present climate and future climate in 100 years' time. So here you can see it's up to up to 30–40% of increase in the most extreme precipitation for the future. On the middle here is the average precipitation, and on the left is the low precipitation events. And there is rather a decrease compared to present day climate. So it is the most intense precipitation that is projected to increase in a future climate. Then looking a little bit more into the what we defined as an ecosystem extreme. So this is the cyanobacteria biomass, and here is past changes. So this is the duration of the vegetation period in number of days. And it's based on phytoplankton biomass and chlorophyll A data. And here is the past 30 years. And there is an increase in harmful cyanobacteria blooms. And this increase is projected to continue in a future changing climate. I will not go through all the extremes that we were looking at, but I will sum up in a table here. And this table is the arrow, so decrease or increase, and how thick the arrow is illustrates if it is a minor or a major decrease or increase. And then the confidence level is an important aspect. Some of this information have we seen indications of, and some of the information we are quite certain of. So the confidence level here we have defined from low to high confidence level. And we have past decades and we have future scenarios. So what we can see with quite low confidence level is that there probably is an increase of number of deep extratropical cyclones, both for past decades and future scenarios. The extreme sea level north of 58 degrees has been decreasing due to the land uplift, but south of 58 degrees, there has been an increase. And for the future scenarios, a little bit what we heard from Markus for the mean sea level, which also is valid for the extreme sea level, is probably an increase both north of south of 58 degrees north, with a larger increase in the south, of course. For the extreme precipitation, as I said, we have seen a slight increase for the past decades, and this is projected to continue for future scenarios. Heat waves, as I said, we have seen an increase, and this increase will continue probably. The cold spells has been decreasing quite a lot in the past and will continue to decrease with a median level of certainty. For the marine heat waves, there has been an indication of an increase in marine heat waves in the past, and this is projected to continue in the future. Mild winters will increase and cold winters will decrease probably, and this is a signal we have seen and will continue to see. When it comes to drought, which is an important part as well as river flooding, it's more regional variability, so it depends on where we are. So north of 59 degrees, there has been seen a decrease in the drought conditions, but south of 59, so in the south, has been an increase in the number of drought events. And for the river flooding, it depends a little bit on the season. To sum up, what we have seen is that, and I would really want to stress, which you probably are aware of already, the climate in the Baltic Sea region is highly variable. It is so now, and it will continue to be highly variable in the future. And this makes climate change signals harder to detect when we have a high natural variability. That's why we have relatively low confidence levels for some of the parameters we are looking at. There is a clear climate change signal, in particularly when we look at heat waves and heavy precipitation, with increasing heat waves and increasing heavy precipitation. We have also seen a decrease in parameters that are cold parameters, like cold spells and heavy icing conditions. The impacts on society and the mitigation aspects needs further evaluation. So this is some brief examples of the review paper that we have done, and this review is part of the Baltic Earth assessment reports, the BEAR reports, which is a set of reports published in Earth System Dynamics and is freely available for those interested. Okay, thank you.
Thank you, Anna. You're really painting a grim picture. It's hard to get sort of your head around all these changes. Would you agree that among sort of us, the general public, I think we've started to realize that, you know, extreme weather will become more common. Would you say that also sort of in policy and the general understanding, has this sort of seeped through? Are people talking enough about the effects of extreme weather?
I just want to nuance what you say a little bit. So we should not think that all extreme weather will be more extreme. That's absolutely not the case. So some extreme weather will be more extreme, some will be less extreme, and some will not be influenced at all. So I think it's important to see about, it's not black and white. So we will need to focus on what will probably be more extreme and see how society can handle that. And of course, society will be able to handle that, I'm quite sure. And there are a lot of discussions in society. And I've been involved in some discussion in southern Sweden, for example, when we talk about increased sea level and maybe a risk of increased river flooding, and the combination of this for coastal cities. So cities need to look into these projections and prepare. And there are discussions, I think, maybe not as extensive and fast as one would like, but there are a lot of discussions on this, I think.
So, I mean, I hear from both of you, you're underlying the complexity, the differences, and the regional aspects of this. So, Markus, will you join us here on the screen? We will continue with talking about this. And I mean, of course, Anna, you have also been part of this CLIME project, and again, it's a very fascinating work. If you go back to the IPCC work and all that, would you say that these parts of what you're talking about now is also really part of the overall IPCC discussions?
I think the IPCC reports are very nice information sources, and we have used this since decades, this information, but never as detailed as we needed for planning purposes on the regional scale. And that was the idea that Baltic Earth many years ago started to produce these regional IPCC reports. They are built on the information. So we can say the global climate information is coming from the IPCC reports, but then additional models, additional assessments, additional data have been used to investigate the detailed changes in the Baltic Sea region. And that is very valuable, as Anna said, for instance, for planning in cities, for coastal protection, for energy, for the energy sector, and so on. And I think these reports, we are doing it now, it's the third round, and I think they have been used for many purposes quite intensively in during the past 2-3 decades.
Okay. So let's go back to this regional perspective of again, stressing the complexity. Would you say that policy issues today are sort of taking this into consideration enough? Are we at a suitable regional level with our policy issues?
I think the discussions are started, and I think we are on the way, and maybe not to the full extent that one would have hoped a few years ago, but I think discussions are started, and I think politicians take this seriously, and city planners and planners in general. So I think the discussions are coming, are ongoing already.
And Markus, you were mentioning in your talk, you mentioned the fact that the Baltic Sea Action Plan was delivering, and you showed the slide over changes of, areas without oxygen in the sea. Do we really need to is it enough to do the Baltic Sea Action Plan, or do we need to speed up to actually counteract these changes?
Depends, of course, what you want. It depends on the targets, and I think that's a political discussion. But HELCOM approached us, so us, I mean here the science community working with regional climate change, exactly due to this reason, because it is now planned to add the climate change aspects in the policy instruments like the Baltic Sea Action Plans, and to get the information how much climate change is counteracting nutrient load reductions. This has to be combined. So we are producing this information really for this purpose. And it is not only nutrient load reduction, there are all other aspects of the Baltic Sea Action Plan, of the other assessments that HELCOM is doing where climate change is important. This has not been done before. So previous planning for nutrient load reductions, for marine protected areas and so on has not taken really projections of climate change into account. But now we are working on that, and therefore I hope that this fact sheet is a first step towards that direction, that the information can be used for policy making.
We have a question linked to this coming in from the audience. Stressing the fact what we just talked about, that the Baltic Sea actions are probably still will be effective despite climate change. And the question is this projection only linked to abiotic factors?
No, I mean, it's the projections are based on models, and these models are, of course, far from being realistic. It's models at what our understanding is of the system, but it includes the physical parameters like water temperature, salinity, and stratification, but it includes also oxygen and biomass. So the whole closure of the nutrient cycling in the Baltic Sea, in the model world. Okay. So the answer is both. The abiotic and biotic parameters are included. But of course, you can argue these models are not so complex that, for instance, food web interaction that may change in future. These models cannot deal with that.
We have a follow-up question regarding this. As you said, the hypoxic area will decrease if we follow Baltic Sea Action Plan regarding continued decreased nutrient load from land. What about the internal load on nutrients from the sediments?
Yeah, they're actually counteracting, and that is the reason that you, if you looked at in my graph, that it will not go immediately. I mean, nutrient loads have been reduced since the 80s already. So there has been a lot of work done already. We are not there completely where the Baltic Sea Action Plan wanted us to have. But there's a time scale, a delay. And this delay is explained by the internal loads. So according to my graph, it's by the mid-century, so around 2050 or at least, say, 2 decades from now on, then we can see clear responses in hypoxic area. Yeah. And this is explained by the internal loads.
Okay, thank you. Going back then to talking about what shall we do and what we would like to see happening. And there's also a question from the audience touching upon this here. If we go back to, we talked about earlier, the uncertainties and the regional differences. The question is, which steps would you expect from policymakers to address in the next 10 years? I mean, if you have your wish list, put something on the top of your wish list and the policymakers will give you this for Christmas. Anna, what would you like to see?
It depends on, so my number one wish is a global carbon dioxide tax. I think that would. And the other one is better. And
sorry, can I just ask? And that would sort of be, even though it's global, of course it's addressing, and the climate is a global issue, I mean, it spreads all over, and that will sort of deal. But what should we do on the regional scale to sort of, complement that?
I mean, so this is difficult. Being a climate scientist, and climate is a global problem, course, yes. and the solutions must be, I mean, if we want to reduce the climate change, the solution must be global. So then I think on a national level, we need to influence the global society. Then adapting to the changing climate, that is something we need to do on a national and a regional level. And then I think coastal protection and coastal city protection that I'm working a little bit on is something that needs to be addressed better nationally, and not leave at least on a Swedish national level, not leave the local authorities to deal with quite big problems that are caused by this global change.
So a high degree of support from national level to deal at a local level with these problems.
Yes.
Okay, thank you. Markus?
I would say the same, of course. Global change is something on a global scale. But I like very much this dialogue between scientists and policymakers. So what HELCOM started to have this intensive collaboration with Baltic Earth and other scientific networks is very good. So that we can provide our knowledge that is directly affecting the policy instrument. I think that's very good. And my wish list is for Christmas that this is going on and maybe even intensified.
Thank you. Thank you, Markus. Thank you, Anna, so much for participating. Unfortunately, time is running out. There are more questions and we will try to get back to them. Thanks a lot again. And to you, the audience, I wish you all a Merry Christmas and a Happy New Year. And you will hear more from us in January. And we will probably talk about the Baltic Sea ecosystem and fish, and from a more historic perspective, and look at changes over time. But more information is coming on that. And hopefully in spring we will meet again and also have these actual breakfasts. Otherwise I have to start calling this something else than breakfast. But let's keep fingers crossed. Thanks a lot and bye-bye for now.